AGI hits the wall. The wall is abstraction. Continuing on Bergson and the holographic theory. We've taken a couple looks at the current interesting point in the evolution of artificial intelligence. The ARC-AGI analysis, why a thorn for AI, and neural scaling laws, scaling on reality. Particularly, these are focused around Francois Chollet and his ARC test. For Chollet, deep learning nets are necessary but insufficient. AI needs generalization, the basis of which is abstraction. Now, we looked at some of these extremely simple to humans tests, the nature thereof, that even OpenAI o3 failed. This one, for example, the example is transforming the left to the right side. And we saw sort of a painting event where we're drawing a painting line from the little blue dots, and we turn the chunk of red blocks blue. Likewise, in the horizontal direction. If we look at this one, we're going to see it's the same thing. Extremely simple. Or this one, where the eye catches, it looks like a kind of a painting event. And the little palette is given there as an example, and we're turning the blocks blue, red, green, light blue, etc. So very simple to the human. But an index then, given AI's failure, of something very different that is being done by the human mind. And we saw that Chollet holds that AIs are just memorizing patterns, memorizing mini programs, as he would look at it, and is working on, memorization resistant test, ARC-2, which he thinks O3 won't do as well on, perhaps 30%, and a far worse version 3. Now, what we didn't know is Chollet is giving AI an advantage. He's working with one hand tied behind his back, maybe both hands. He's given the 400 public tests to train upon, thus memorize the patterns appropriate to these kinds of tests, hoping for intersections, that is, programs that might emerge that apply to things that the AIs haven't seen yet. The question would be, what is an AI's performance without this training? A true general intelligence should have no problem, as we just kind of see from at least these couple examples. So yes, but what is abstraction? What is its basis? This is where Chollet goes astray, along with the rest of AI, along with the rest of cognitive science, because the brain is an entirely different form of device than AI folks can conceive. Therefore, the nature of abstraction is entirely different from what they can conceive. Achieving abstraction is AI's wall. And if we look there, that wall is one heck of a wall, 13,171 miles. Boggles the mind when one thinks about it. So, let's see why this is the wall. I'm going to bounce off this talk by Chollet in 2021, the AI paradox. AI models have excelled at solving specific tasks without displaying any intelligence. He starts setting the scene, the state of AI in 2021, extremely good at specific tasks, but zero progress on generality or any broad cognitive development ability. He notes modern AI is data hungry. It does not withstand well contact with the real world. It's brittle. It fails in ways that reveals a lack of adaptability. In general, a lack of generalizable cognitive abilities. So this is where he's coming from in 2021. He takes an example, this game, Dot A2. They trained on 445,000 years of data. It was a restricted version of the game. Humans could figure out how to beat the AI in a few weeks, but the AI can't adapt to simple rule changes. He knows it's always possible to create shortcuts to solve a given task without featuring intelligence. And he brings up Descartes' quote from long ago, 1637, even though such machines might do some things as well as we do them, Or perhaps even better, they would inevitably fail in others, which would reveal they were acting not through understanding, but only from the disposition of their organs. This is coming from the guy that invented abstract geometric or algebraic geometry. Might want to pay attention. Another thing he notes, generalization, not task-specific skill, is a central problem in AI. Generalization, the ability to handle situations or tasks that differ from previously encountered situations, dealing with uncertainty, dealing with novelty, displaying autonomy. All this is true, but kind of surface effects. From whence does this ability arise? So for Chollet, what is abstraction? Well, he's got this as a slide. Two poles of abstraction. One prototype-centric or value-centric abstraction. The other program-centric abstraction. Abstracting, generalizing programs. Here's a quote. These are two qualitatively different forms of abstraction, and so both of them are driven by analogy. Both are driven by analogy. Analogy. It's going to be a key. There are ways to compare things and draw analogies between things, but a value analogy is geometrically grounded. You are comparing distances with a distance function. You create abstractions by merging instances that are similar into a prototype. So we'll take a look at that in a second. In program analogy, is topologically grounded. You compare the structure of two graphs and create abstraction by merging instances into an abstract program. And all this intelligence arises from a combination of these two forms of abstraction. So, pretty interesting thesis. So the prototype-centric will be neural, deep learning, net-based in Chollet's vision. Program-centric, we'll see. He thinks this dichotomy roughly corresponds to type 1 and type 2 thinking that we met last time, and thinking, it was Kahneman's thinking fast and slow, that AI is now seen as these two major forms of thinking. And even more roughly to the left brain, right brain dichotomy of McGilchrist. And he shows this slide with perception and intuition being the right brain, planning, reasoning, rigorous abstraction on the left side, so left brain people. So we'll focus first on the value-centric. It's the start of where he goes wrong. So he says deep learning is the first form of abstraction, to quote. So abstraction of a prototype. This is based in neural net algos, deep learning. It's viewed as perception, as the piece of the slide I'm pointing to shows. Talking perception here. So note the quote there. A value analogy is geometrically grounded. You are comparing distances with a distance function. You create abstractions by merging instances that are similar to a prototype. So we're seeing the abstract prototype of those 9 real faces. And his point there is if you take that prototype, you can generate any face. I'm picking what face is it I'm thinking? I think the top right with the glasses. And you can generate that via a mapping function in terms of distance of points from the prototype and just distance and color, for example. Now the glasses, of course, are they part of the face? That's an interesting question. Our concept of face is far more dynamic. It's part of events to include seeing or doing the putting on or taking off of glasses. So we're already going to get AI in trouble a bit with our glasses part of the face or not. Notice I said dynamic. Chollet and AI think in static terms. This is where the problem begins. Yes, we can make an abstraction from static snapshots of coffee stirring. What is an abstraction across all of these as dynamic events? In Chollet's AI framework, we'd have to store a series of snapshots of each event as it's ongoing, snapshot after snapshot. Each would be a grid of pixels, correlated as weights. The 9 there is ultimately something that the net responds to as a correlation, highest probability being that's a 9 via its weights. We could stick a coffee cup there too, same process. But how does such a series of snapshots actually capture the dynamics? This again being the dynamics, the velocity flow fields, the adiabatic ratio, energy of oscillation, the frequency of oscillation. The inertial tensor, which is the information carried over a haptic flow field that's specific to the actual length of the spoon. Acoustical invariance, texture gradient, so multimodal and very dynamic. One has to sort of register this, what's really going on in this very concrete event. How would the brain do this? That is, treat this in terms of snapshots. How and register the concrete dynamics? How and yet see the event as ongoing? Are you going to introduce some internal scanner that scans the snapshots? How does the scanner register the motion? Now you have an infinite regress problem. Now you have to explain how the scanner represents motion, registers motion. Worse, we're really scanning this. The whatever you want to call it in the computer, weights, states of magnetic cores, whatever, that's what you're scanning. You're not scanning an image. So the logical problems are in truth overwhelming once you introduce the dynamics and ask how we're perceiving the event as ongoing. So the brain does not, it cannot. We noted Gibson, for him, the brain is resonating to this dynamic structure, which is transforming in an indivisible, not state by state, snapshot by snapshot, time. It is a 4D extended flowing time. Another example why it cannot be doing this. Remember our discussion of the rotating wire cube, where we're strobing it in phase with its symmetry period. That is, strobed in phase, 4, 8, 12 times per full rotation, we see a rigid cube in rotation. Strobed out of phase, 5, 19, 13 per full rotation, we're seeing a plastically deforming, wobbly, not a cube. But the strobe is a sample, a snapshot. If a static sample is enough to specify form, why not always seen as a cube? Why are we not always seeing a rigid cube? It's because the brain is not and cannot be doing static sampling. The saccades, the motion of the eyes from point to point to point, are actually sampling flows. It's a misconception to think the saccades are taking static snapshots. So why does AI think the brain can do this? Because that's its model. That's the metaphysic it works in. Again, one could ask, at what scale of time do these samples represent? Again, noted lots of times. Fly going by the stirring, his wings a blur. It's an index of the scale of time. What does a coffee look like, and along with the fly at these scales? When you have a heron-like fly flying by, the coffee's all going to slow down. The liquid's going to start looking differently. How about a fly as a cloud of electrons? Well, now, so the hand's going to look somewhat like a cloud of electrons. So the spoon, the liquid's going to be quite interesting in its perceptual presentation. So the brain's underlying chemical dynamics, velocities I've noted, impose the scale. And I'm very serious about this. This is in the literature. This is in peer-reviewed literature. How this works. How LSD, for example, slows down the perception. Slows time down, slows this whole event down. What's the biochemical action that's required to do that? AI just assumes the time scale of the image, as though this does not have to be explained. This is the problem. The origin of the image, the time scale of the image, and the problem of qualia, they're all the same problem. That is, again, as I've noted several times, when the hard problem is understood as the origin of the image of the perceptual world, the external world, and of course that's disputed because it's really just the feel. How does it feel? How do we account for the feel of things? No, it's the origin of the image, and the image, the scale of time is the qualia of the image. So you cannot get away from the hard problem in solving the origin of the image. So AI doesn't think it has to solve this, but this is all part of AI's problem. The storing of snapshots problem is very serious then. Again, putting that quote up. You create abstractions by merging instances that are similar to a prototype. Again, what is abstraction? An analogy when considered dynamically. So again, we've got that invariant structure. This is what I've argued on the process of redintegration. The structure of the dynamically changing event, that invariant structure, is driving the brain as a resonating mass, a waveform. It's like driving then a wave through the four-dimensional extent of experience. You're getting this, we'll call it a sympathetic resonance. That structure, that wave is driving through it. The variants of each event in our experience wash out. The invariants remain. This is a concept, an abstraction, the concept of coffee stirring. This concept is inherently dynamic. That is, it's not statically defined. It's ad hoc. Taking this from Casasanto and Lupien. All concepts are ad hoc. That is, all are dynamically formed via retrieval cues in the moment. Our coffee cup the guy's looking at is the retrieval cue. No concepts are ever stored. All are being created in the moment via context-dependent retrieval of experience. We've talked about the context dependency, but it's also content addressability. No concept is ever quite the same from one time to the next. This can't be true of this, a static set of large language model vectors, where we're representing the event, like via these vectors, spoon, coffee, stir, etc. This has nothing to do with this invariant structure, the concrete forces and variants defined over the concretely transforming experience. So analogy, this content addressing retrieval process via redintegration is inherently analogical. Suppose an anomalous event I've noted, like our coffee going up and down there. Well, there's going to be a dissonance. It's not going to match with that concept of coffee stirring. But what does the event also retrieve? Well, it's going to drive a resonance again through with events with that structure, rising dough, pistons, etc. Well, even a UFO pulling a cow up and down. This retrieval operation is the foundation of analogy. Remember, for Chollet, analogy is the critical thing here. But analogy forces us to store every single one of these samples or snapshots. In reality, the dynamically transforming events. Totally, infinitely, I said. Else, see that we are 4D beings, where we're not actually storing it at all. That's the Bergson position, but we won't repeat it at this point. But why? The need for storing the entirety of our experience and the mechanism of analogical reminding, this was Hofstadter and Sander's dilemma in this book, Surfaces and Essences. Noted it before, but it's worth looking at it again in this context. Hofstadter is visiting the north rim of the Grand Canyon with his son Danny, and in the midst of the scene of great majesty and splendor, Danny bends down, intent on watching some insects in the sand. We'll call that the event, E, original event. Many years later, he is visiting the great temple of Karnak with his friend Dick. And Dick suddenly seems more focused on bending down and peering at a small bottle cap, an object for which he has an obsession for collection, on the ground. So that's the current event, E prime. So the former scene of the Grand Canyon comes rushing back to Hofstadter in memory. So E prime is redintegrating E, analogically. We have, in other words, an analogical reminding, what I've termed, way back from 1732 with Christian Wolff, his terminology, a redintegration. Pattern in the current event, retrieving via a previous event with the same pattern. So if Hofstadter, DH, had encoded the abstraction, that is the concept at E, then only analogies with such encodings are impossible. The concept here, quote, attention on the trivial in the context of a grand geological or architectural scene of great majesty and splendor. But this encoding at the time of the Grand Canyon event does not track with experience because analogies are voluminous, inexhaustible. They saw this volume of analogies, inexhaustibility, required storage of the totality of our experience. But how? We noted they considered and they rejected the idea that events were stored as unindexed videos on DVDs. Therefore, you'd have the Grand Canyon on some disc and the Karnak on another. And when Karnak comes, you've got to search through all the discs to find the Grand Canyon. And of course, the idea would be, well, if you pre-encoded things, like encoded attention on the trivial on Karnak, then maybe that might be indexed on these, such that you could find an index that said, oh, here's a disc with the Grand Canyon. But they rejected this because they don't see how they can store all of experience. Well, we've discussed that many a time now, and why in Bergson's model you're not storing experience. But this is the takeaway for the operation of analogy. The entirety of an event, its full dynamics, must be stored. The entirety of our life, our in 4D experience, in complete detail. Also, this redintegrative content addressing. Remember, you're not looking for computer addresses. The content, the nature of the event, recalls a previous event with the same nature or pattern. This redintegrative mechanism is required. This attempt, our vector spaces, this is trying to encode all of our experience. But new analogies based on unencoded experience will always emerge. You cannot label everything in that coffee stirring event. We choose to label some things, designate some things as concepts, like spoon, like cup, like liquid. But you're not designating, you cannot describe the entire event. There's always going to be things within that event that will contribute to future analogies. So this is a lost cause, this vector space built on a 50,000 word vocabulary. In other words, Chollet's and AI's conception of value analogy is very far away from the human operation of analogy. I noted this again, just for the heck of it, in this article, the paradox of Hofstadter-Sander. Why is it a paradox? Because, as we kind of indicated already, per Hofstadter and Sander, analogy creation shouldn't be possible. It is impossible unless you have a four-dimensional being and a memory defined as such. So this is all of a piece. We started with perception, AI's misconception thereof, And everything so far underlies AI's problem with abstract thought. We noted this time-flowing dynamic structure of events, the set of invariants, forced Gibson to argue that the brain is resonating to this dynamic structure, which is to say the brain is not sampling, not taking snapshots, not storing these, for there are no logical points during the event to store anything in the first place. And as such, there's no processing of images and a static pixel groups per AI in reality in the brain. This entails a model of the origin of the image of the external world, our experience. We've noted it several times. It's a holographic model. The universe is a holographic field. The resonating brain, that resonance is the forms comprises the reconstructive wave passing through this field and specific to an object then within the field, as the object wave is specific to its source, the cup there on the holographic reconstruction thing. This is another key thing to note, though. This is a multimodal specification of the event. Specification to its optical, to its sonic, to its kinesthetic aspects within the external field. This is a transduction to a homogeneous medium, a computer memory. The multimodality is lost. It's not recoverable. Give the computer a camera, give it a robot arm, give it a microphone. All that information in the sonic and the optic and the kinesthetic is transduced to this uniform computer memory. In other words, the event is gone. The multimodal event is gone, and it's not recoverable. Again, I'm just kind of noting, this stuff is in the literature, and I've kind of complained about AI before, picking and choosing literature that needs to pay attention to. Well, this is one it should pay attention to. So, again, this model entails then ultimately our use of experience as imagery and thought. AI, it should be understood by its intrinsic structure from its initiation, rejected any use or need for imagery and cognition. In fact, by its model, AI is precluded from this. And I noted in one of those two previous ones, I think the first one, its inception already in 1973. One of the cognitive theorists, Zenon Parlishin, in other words, he says, the image has lost all its picture-like qualities and has become a data structure, meeting all the requirements of the form of representation set forth in earlier sections. It can be put in one-to-one correspondence with a finite set of propositions. Well, that's exactly what we're seeing with the vector spaces. Similarly, seeing the image has been replaced by a set of common elementary and completely mechanical operations, such as testing the identity of two symbols. This mindset has never gone away. This no imagery needed framework is Chollet's. This is the framework they're working in. Basically, with both eyes, this is how they've got both hands tied behind their back. They're trying to do cognition without imagery. It's like saying, oh, here the universe provided us with vision, with hearing, with olfaction, with kinesthesia, haptic ability, but we don't need any of it to do cognition. Throw that all away. We can do cognition without any of it, as long as you give us a vector space of words. So this no imagery needed idea, it underlies this definition of program analogy. So he says, program analogy is topologically grounded. You compare the structure of two graphs and create abstraction by merging instances into an abstract program. And all of this intelligence arises from the combination of these two forms of abstraction, as we noted. And he's got a picture there. I blew it up. Here's two little programs, and the idea is you look at them and merge them into a higher order program that does the same thing as the two little programs. Now, obviously, we'll look at this later, but you can glance from the human eye sees why it can be done. But he says this will be done in terms of, when it gets more complicated, obviously, a structure of graphs. We're relating graphs. This looks a bit visual, but it has nothing to do with visual imagery based in topology, like we would look at actual knots. This will be an abstract array of address pointers to nodes. So continuing on programs, he says, when you look at an ARC task, the space of possible programs to the objects you see is extraordinarily large, millions and millions of programs. Yet when you look at the ARC task, in your mind, you're only considering 2 or 3 possible solutions. So you've managed to radically prune the space from millions of programs down to a few. And you've done that without thinking about it. It's not reasoning. You've done that via pattern recognition and intuition, that is perception. But I'm going to say it is our reasoning. It is our cognition. It is precisely, once you get past the pattern recognition, shall we say, the operational per Piaget, flexible, reversible, mathematical group-enabled use of our experience in the form of imagery. This operational imagery is the programs we are running. So when we look at this, yes, we see, all right, there's our thing. The initial intuition, the program space pruning, is via redintegration. The pattern we kind of pick up, looks like we're painting things. We see retrieves a painting or a coloring event. The imaginative operation, the brush is filling each block touched, and that's pretty obvious. But suppose it looked like this. It's going to get a little more complex. Again, that's how we look at it. I've changed it a bit. We still see the painting event, but now we imagine, seeing the vertical brush, that the brush is also, for some reason, or somebody is flipping the red block over to the other side of the line, to the other side. So we're imagining that flip, or you can slide it over if you mind if you want. That's where we're starting to bring in perceptual operations, the operational imagery. So we have the initial redintegrative analogy, which pairs the space down. But we've got some work to do conceptually, perceptually. There's an enormous amount of such variations on just this painting test alone. I mean, hence the millions of programs. For example, when you look at it, I just flipped the blocks on the vertical. I could have flipped them over on the horizontal too, with a little bit on the work on the right side there. We could allow for the same kind of flipping as the line draws. We could flip. We could do all kinds of things. We could take one little red square off and flip it around to on the top right corner, and always put it down below in the bottom left corner as one of these blocks changes. In other words, you could just make a ton of different changes that we could see through fairly quickly on just this test alone, hence the millions and millions of programs. But our programs are this infinity of manipulations of experience as images. Same as this, noted lots of times. Taking the parallelogram, turning it into a cylinder, and saying, now we can make a rectangle. Or Penrose's stacking and folding of hexagonal numbers into 3-sided cubes and making a cubical number invariantly. Notice, is that not reasoning? Wertheimer's figuring out how the sum of the angles around the polygon is always 360 degrees, bending the line, breaking it, always seeing there's 360 total value of the angles made. Or this, which we talked about the other time with Piaget, with the reversible imagery for the concept of number. We've got the one-to-one correspondence that initially flowers to vases. We take them out, bunch them together, asking the child, do we have the same number? Or bunch the vases together, ask the child, do we have the same number? Ultimately, the child, to answer that question correctly, has to be able to have reversible operational imagery to understand and answer the question properly. Or this, a Piaget conservation task, or two equal glasses, we pour the glass into B1 and B2, and now we say, do we still have the same amount as an A1? Again, the children can't answer that initially, but eventually with reversible compensatory, compensating width by height imagery, they can do it. But you're not going to call that reasoning. Interesting. Let's stay on the initial pruning of program space for a second. Why do these patterns not redintegrate events for AI? I was reminded of Bob Verbrugge's experiments. This is back in 1977. I put the reference there. A memory experiment. So he presented a set of metaphoric sentences in a series such as, the Venus flytrap is like a prison cell, waiting for its next victim to enter. Or the dictator's treatment of people is like a boot crushing a bug. Later, he gave these kinds of cues for recall. What would that redintegrate? Or this one. Looks like the flytrap. He argued, and by the way, I should note, these were very effective cues for if he gave the people 20 sentences, they could recall them all via these cues. So he argued the comic strips captured abstract perceptual relations characteristic of the event, specified in each sentence. In other words, they're reflecting abstractly the invariant structure, the engine of redintegration, E prime redintegrates E. In other words, again, the sentence is activating the event invariant structure. It is the basis for comprehending the sentence. Just as a historical note, I took a 9-day canoe trip in Quantico Park in Canada with Bob Verbrugge in, I think, roughly 1974. This is when ecological psychology was exploring its power in explaining memory. And Verbrugge did some real interesting things if you look his name up with metaphor. And since then, ecopsychology has lost the plot on applying itself to memory, which is sad. So my thought, well, yeah, ChatGPT will recognize these kinds of abstractions, like the boot saying on the bug there, as pictures. It can kind of do this. I gave it this picture. And my query was, given pick 1, pick 2, and pick 3 in the figure, show me a picture or a description of what pick 4, part B would look like. And it kind of did it. It said, pick 1 where the incline is changing, affecting the movement of the weight. Of course, we see that's a little bit of his failure of physics. I mean, when we look at the pick 1A there with the weight, we know that weight's going to fall because it can't possibly be balanced by nothing on the other side. So he's thinking the incline. ChatGPT is saying, well, the incline, somebody must have tipped the incline and the weight fell down. The second one says the weight drops into a trash can. To me, it looked like it crushed a trash can. A person jumps on one side of a seesaw, launching the weight. Pick 3 there. Okay, that's pretty. I kind of missed that too. But finally, he says pick 4. The weight is above the coffee. Based on previous pattern, the weight will likely drop into the cup. And so he says prediction: the image would show the weight falling into the cup, possibly splashing the liquid. So it looks like it kind of got it, except it clearly doesn't understand much of the physics. I would say because it doesn't have a clue about the invariance. It's never experienced the invariance structure, the events with the invariance laws. It's just not there. But it's trying to fake it. So given its image to text functionality, where the images in its data set are labeled, for example, falling weight, pulley with ropes, it can kind of do this. relative to that mass of vectors it has. I gave it a yet more abstract set of pictures, more of a Brugge-like. And same kind of query. And then it says, well, in other words, what's going to happen in pick 4b? It says the blue shape lands on the black shape for pick 1. I said, well, I pretty much crushed the black shape and pretty much squished it. But all right, the black shape falls, causing the black shape to tilt. Black shape falls. I'm sorry, the blue shape falls on pick 2, causing the black shape to tilt. Kind of strange. It's not falling. The blue shape hits the black shape, making it tip over. That's kind of good. And the blue shape moves toward the black shape. And he said that the black shape should fall or be knocked over in pick 4 part B. And then it gives me that picture there. So some success, obviously not a whole lot of understanding of the actual events. So then I thought, well, what if I give ChatGPT? I know ChatGPT is not O3, and it's not going to do this. But I thought, what if I helped it with giving it the event? So here's a query of no help. Given the transformation from A to B in each picture, pick 1, pick 2, pick 3, show me what pick 4b should look like. And it says, well, the red blocks from A remain unchanged in B. 2, the blocks appear in B. In 2, the blocks are added in specific ways, sometimes forming structured patterns. Anyhow, pick 4b, it says, the red blocks will likely remain unchanged. A pattern of blue blocks similar to previous transformations should be produced. And there's this picture. I mean, okay. I tried again with I tried several, actually, with lots of help, different forms of help. This one I thought was almost giving it. Given pick 1, pick 2, and pick 3 in a figure, show me a picture or a description of what pick 4 part B would look like. Imagine that a paintbrush is painting a line from the single blue square at the top to the single blue square at the bottom, and painting every set of red blocks that it touches. Imagine that paintbrush again paints a line from the single blue block on the left side to the single blue block on the right side, also painting blue every set of red blocks that it touches. And it kind of says things that make sense. Unfortunately, there's the picture there up on the right above the text there. It says pick 4 should look similar to pick 3, with several red blocks that are touched by the vertical and horizontal, reading the bottom there. Vertical and horizontal brush pass turn blue. Actually, I had a better one where it said it should look like pick 3, where there should be the crossing of the two lines and the blocks turn blue, but it didn't generate a picture for me because I ran out of. I'm doing the freebie here, and I said I won't do anything more till tomorrow, and then it changed its answer the next day. But anyhow, you get the idea that it doesn't really get the idea. Even with help, in other words, I'm going to give you the event pattern. Doesn't work. What is the core problem in all of this? I think it's this. Verbrugge's abstractions, that is concepts, arise from and express a far different source than AI's concepts. Doesn't really have concepts. Again, you have the concept of the crushing event here, the redintegrative wave passing through these concrete events in the optical and the sonic, the kinesthetic, including ourselves doing crushing. The guy could be trying to crush the ball himself there with the real kinesthetic visual feedback all simultaneously. This, Verbrugge's, is only a higher abstraction based in this abstraction process. That's the real, the abstraction process with our guy with the wave there is the real source of Verbrugge's abstractions. So the abstractions ChatGPT somewhat recognizes are not the same, not derived on the same basis as that of humans. Nor is labeling static images, that is pixel groups again, really, and tying these to vector spaces close to sufficient in capturing this dynamic process and structure. So even this process has imagery undergirding it, our program analogy. When I look at that program, I say, well, I'm just looking at the A equal 4, 3, 2, 6 there. For I equal E enumerate A. Well, A to me is a box of things in which I'm sticking the 4 numbers, 4, 3, 2, and 6. Let's change this statement for just to make it a little clearer. We'll put start equal 1. Otherwise, it starts at 0. Makes it slightly more complex. So enumerate says, well, do this. Pull each object out of the box, which we do. And then we look at this statement here, plus equal I times E. Well, I is our index, and we're multiplying the index by the thing in the box. So here's our index, 1, 2, 3, 4, times the number in the box, and we're going to get then that as a total. Now, I could do more visual imagery underlying that addition. I'm absolutely certain there's more visual imagery as we learn as young children what that means, what adding up those 4 things mean. I'm just sort of giving the start here. For Chollet, noted how slow the brain is, on order of 50 milliseconds, simply not time for us to chunk through hundreds of steps in this particular case. Or in what's in reality for the computer, or the massive computing operations required for even one of these tests based on horsing around pixel groups. And the massive matrix derivative computations on pixel patterns. Again, I might not have noted here. Chollet is thinking, well, what's really happening is we start to synthesize little programs. That's why he's got the program-centric abstraction, and the way he's going to synthesize programs is via his emerging of graphs. But as noted last time, or time before last, on the Chollet test, ARC-AGI, why it's a thorn. Sloman had already pointed this out, that we need this analogical representation. And especially in this case, where we're looking at problems, as he says, there's simulations of perception and problem solving. And that little pulley there was this figure. But note, again, just like Verbrugge's abstraction, that is founded in all those concrete experiences on the left from the redintegrated process that actually give meaning to that analogical representation that he's pointing to that's necessary for intelligence. And then we have to remember this. We know that the boards don't stretch or shrink in that analogical picture. That is, there's many physical constraints implied via our knowledge of what's happening on things in the left there and what we've experienced that are implied in those analogical pictures. These are forms of ARC tests too. For example, we could show various pictures as to what's correct physically. AI does not have the representational power, I repeat. Why? Because it has no model of the image, origin of the image, the multimodal image of the external world, thus of imagery and thought, thus the basis for Piaget's operational imagery. This, the origin of the image, is the hard problem. For AI, it is the wall. So next we'll see, again, most of this discussed in this book. if you want to take a look. So till then, much later, signing off.